In this stoichiometry problem, we are given amounts of all reactants, and we're given the reaction itself, the chemical equation. So we can simply fill in the chemical equation in the first line of our IRF table. We've even been given a balanced chemical equation, so we're getting a bit spoiled here. We do need to convert the amounts that were given in grams into amounts in moles, because it's always only moles that go into our IRF table. So to fill in the initial line, that is the initial amounts of each reactant that we have, we must take the initial amounts in grams and convert those to moles. We do that by dividing the grams by the molar mass of each reactant involved. When we do that division, the grams cancel out and we're left with moles. Once we figure out the moles of each reactant, we put those into the initial line of our IRF table. Remember, at this stage, there's no consideration given for stoichiometry. This is simply what you have to do the reaction with, what amounts of each, the initial amounts, regardless of the stoichiometry of the reaction involved. It's really important to remember this. Once you have these two amounts in moles, you pop them into the initial line on your IRF table in the appropriate place. Note that there's a third reactant, water, but you were told that water is the solvent in which the reaction occurs. So what we would say is we have lots of water or excess water, and it won't figure into any of our calculations any further. Given these initial moles of each reactant, we can now make an educated guess about which one will run out first. Remember, if you make the wrong guess, the only problem is you get a negative amount of excess of one reactant. So if we assume that the SO2 is limiting, that tells us that the number of moles of oxygen consumed would be half the number of moles of SO2 consumed, and that gives us a positive excess amount of O2. So therefore, we've chosen correctly the limiting reagent to be SO2 and the excess reagent to be O2. In order to complete our IRF table, the next thing that we want to do is calculate the theoretical yield of our product. This is the amount of product we'd get if everything went great. So we can turn to our IRF table and extend the R line if we know how many moles of our limiting reagent were consumed. We know how many moles of product formed. In this case, the limiting reagent, SO2, is forming product in a 2:2 ratio or a 1:1 ratio. So moles of SO2 consumed equals moles of sulfuric acid produced. For a yield, we would like to have that in grams, so we convert the moles of sulfuric acid into grams by multiplying by the molar mass. Once we get that yield, that theoretical yield, that's if everything went well, but we're told in fact that we have 598 grams of sulfuric acid produced, not 612 as we thought theoretically. So to calculate the percent yield, how well the reaction performed, we take that actual yield and we divide it by the theoretical yield, kind of like your score on a test, and we do convert that to a percent. And once we get a percent from that, then we have more of an idea of how well the reaction was performed or how efficiently it proceeded. Remember that you'll still pay attention to significant figures. You have 3 in the final answer.